This session is a pre-Q&A session. The first pre-Q&A is about how does ECDSA apply to the blockchain process. The following is a representation of the operating logic of ECDSA and simple Python code that applied it to the blockchain process. In the figure to the left, D is signing logic, means the private key of the signing users, and is implemented via line 16 of the code on the right. Q is public key, calculated by ETCs corresponding to line 17. And K and X correspond to an ephemeral key for signing and correspond to line 21 through 23. And line 22 means K.G, which means that add operation is performed K times. And the last line of the signing logic means to generate a signature. And the verification process is computed throughout the following process and is considered valid if the key value derived from the next verification process matches the key value in signing logic. The implementation code for the verification process exists on the subsequent slides. The code on the right is step-by-step representation of the ECDSA signature and verification process. Functions such as generate private key and generate public key are assumed to be pre-implemented. Line 7 through line 12 represent the domain parameters of SCP-256K1. The signing logic starts at line 16 and has already been described earlier. Line 25 is a code that generates transaction in which the sender sends 0.01 coin to the receiver. The fee here is 0.0001 coin, and it is assumed that a large amount of coin exists in the sender's wallet. Line 30 through 33 are the process of the hashing message to sign them. The hashing message here is transaction. Line 35 through 37 represent the last line of the signing logic of the previous slide. Starting with line 48, the verification process is called representation. Line 48 obtains the inverse source of S and stores it in W. Line 49 and 50 are codes that obtain the values U1 and U2 requires for the verification procedure. Line 51 and 52 perform the U1.G and U2.Q operation necessary for verification. The following operation correspond to those used by generate public key. In line 53, the X and Y values are obtained through operation. If this X value matches the previously obtained R value, this signature is a valid signature. The next pre-Q&A is about what is sample code of the out-of-box vending machine service. The following code indicates simple vending machine operation using Node.js. RPC function.js has included function via API on the out-of-box client. RPC function.js line 4 through 14 represent the function for transferring PTCs. The amount paid to the address to the recipient is transferred. This code has no exception handling, but only simple remittance processing is implemented. App.js is a brief description of the vending machine server code. From line 22, when an event occurs, the pay Pyeongtaek coin function is executed and the notification message is output if it is settled normally. The last pre-Q&A is about what is the specific difference between PTC and LTC. The following code shows the difference between LTC and PTC. Left side code is LTC and right side code is PTC. We introduce only some important parts because we cannot show both the difference in code between LTC and PTC. It is a function that creates a Genesis block from lines 50 to 55. Change the timestamp value on line 52 and the public key value on line 53 to the newly created public key value. Line 122 is the code for generating Genesis block, and line 123 obtain the hash value of the Genesis block. And line 124 verifies the integrity of the Genesis block by comparing with the hash value of the obtained Genesis block and hard-coded hash value. And line 125 compares the obtained multi-loot value with the hard-coded multi-loot value to verify the integrity of the transaction. Line 78 is the code that sets the half-life. So whatever you will apply the half-life every few blocks, because PTC does not have a half-life. It is set to the number of blocks issuing coins. Line 84 is code that set the difficulty of mining. This is a set of the difficulty code. Because the mining speed needs to be faster than LTC, so mining difficulty is lower than LTC. Line 86 is where the targeting mining speed is set. PTC aims to generate 1 block per minute. It means 1 minute multiplies 60 seconds.